Okay, so uh, first of all, is the screen can be seen clearly? My screen
It's a little bit too bright.
too bright. Okay, maybe can someone help me to maybe switch the front light? Oh, wrong. I think yeah, maybe yeah, the one. Oh, wrong. Maybe the top one. Okay, thank you. I think better, right? Better. Okay. All right. So okay, because this is an offline class, so I can see at least your eyes whether you're focusing on the lecture or not. But I believe since the very first chapter is just like a review, and I think most of you already learn and know the terms, so I think should be okay. It should be okay. But if you are maybe wondering, like you want to know more, please let me know. Okay, maybe you want to ask a question or maybe something to discuss. Okay. Okay. So for the first one here, let me just uh, quick review on what we have done on the last sections yesterday class. We are discussing how to make a new function from old function. So it's practically one function and you want to make a new function out of that old function. I think it's to you want to yeah maybe turn on yeah
It's super hot.
yeah should be and sometimes there is a fan if you want to also turn the fan also okay the blue one. But I'm not sure whether they are functional. Sometimes they one or two is not functional. But you can try. Yeah, it's running. Yeah, yeah, it's running up. Yeah, yeah. I think just for your information, for because you're freshman, whenever you go to the class and you feel hot, just turn on. Okay, just turn on. That's okay. You don't need to wait for someone to turn on for you. You can just turn on by yourself. Okay. All right. Okay, let me go to this new functions from old function. Basically, we are going to make a transformation. A transformation. The first transformation that I reviewed yesterday is how to shift our graphs. Okay? So by this shifting method or translation, we can see how the functions can be moved. So it can maybe it will make your perspectives different. Okay. So for example, when you see functions like x squared plus 1, you will know that it's just a typical x squared, but shifted to the right, 1 unit. Okay? And whenever you see something like this, so instead expanding the equation and then write the roots and graphs, the vertex, blah, 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 you will know that this is just a typical x squared, but you will move to the left and to the right 1 unit and to the top 2 units, right? So I think it can help you to visualize the functions easily in your mind. So rather than like maybe expand the equation and then find the roots and then write the vertex and then draw by yourself, plot the graphs, I think it's better if you know how they shifted from their usual graphs, right? Okay. I hope that helps. So that's the translation. And this is how it looks like. We can move up and down, left, right. Okay, no problem. And then after this translation, we have reflections, reflection, mirroring. Okay, and then stretching and shrinking. Okay, so stretching if you multiply with some constant. Okay, the constant can be if less than 1, we can say that it's going to be stretched horizontally or shrinking. Okay. Or if you want to write in more formal definitions, what will happen, I will share to you the another slide, another page here. Let me just put, I think this is for the vertical and horizontal shift, okay? And this is for the vertical and horizontal stretching and reflecting, okay? And when we finish all the chapter, like for example, we are still chapter one. When we finish chapter one, I will share the notes like for chapter one, so you know you can. I think easy to organize your notes, okay? And then you can check your own notes with my notes, okay? Which one is? Maybe you still feel confused, or maybe you want to study more, okay? So vertical, horizontal, I think already been discussed since yesterday, and now we have this vertical and horizontal stretch and reflecting, and how to visualize and how to make it make sense to your logic. First is you can imagine one simple function that you can draw easily, and then you can maybe tweak some numbers and then try some numbers and make a plot, okay, to see whether it's stretched or not. So when you've done that, I believe it will help you to understand why this is happening. Okay, so for example, you can try to make, let's just say we still like using the x squared, and try to multiply with constant. What will happen? Okay, and then I think that can be done also. And another way is if you multiply the x, okay, not the y, not the function itself. Like for example, the case for the third and the fourth, then you can also multiply. Like for example, making this or making with this also. And then what will happen? And then you will see that it's actually you are going through this statement. So we can see how the functions will be stretched or shrink by a factor of that constant. Okay, because you multiply with that constant, right? Either the function itself or the x itself. You substitute with the new multiplied x, right? Okay. And to reflect is also the same. You can always try to substitute your x with the negative part, or you can multiply the whole function itself with negative. And what will happen? You will see your plot will reflect it. Okay? Either it will reflect it through the y-axis or reflect it to the x-axis. So whenever you forget, it might happen. I also experience like, is this or that? You can check with a simple function, and then you need to like to make your own statement true. Okay, whether it's reflected to y or x, you can try to draw a simple function and just make it up. Okay, in case you forget. So for me, mathematics or calculus is not about memorizing your like basic formula. Okay, but to try to understand how that formula came from. When you understand that part, you will know how to derive your own formula. Okay, so whenever you forget, like I usually forget my own formula, so I need to know how the formula came from. So that's how we can solve most of the problems if we understand how the process is. So that's my tips for you. So if you maybe still not really understand and you try to memorizing without that understanding, you will forget as soon as possible. Like maybe the day after the exam, you forget everything. And I think that was happening in, I think most students, they feel that way. I also have that period of time, like I just memorizing, oh, this way, this way, this way, all this method. But then I forget everything. Okay. Okay, another way, and if you want to review, I'm recording this, so you can check later on. Okay? Another, just an additional notes on not this one. Wait, this one is the trigonometry. I think trigonometry is quite understandable because if we are looking sine or cosine, they will only have like the maximum is 1 and -1, right? So if you see that when they multiply, and they will have sometimes they will have zero, right? So you will see that the amplitude, the one that is maximum or minimum, they will multiply with the constant we are multiplying, right? Okay. And if you multiply the x itself, you will see that it will change we call, I think in physics, the phase, the degree. They will go to the zero, right? So here we'll see that for the first one, we'll see that the difference here, right? When we multiply, if we multiply with 2, this will be this high. And then if we multiply with the below 1 or between 0 and 1, this will be the amplitude. And 0 stays 0, so you will see that they will meet it at the exact same point for everything here for the same. In our case, this is the 90 degree, right? And then if you multiply with the constant inside this x, okay? So when we multiply with the x itself, not the function, we will see that our phase is they're changing. So you can imagine that the cosine getting 0 at 90, right? At 90 degrees, but we have half, so it should be twice more. So it should be shifted to the right more, right? Okay, I think it's logical, like makes sense, right? Okay. So I think sometimes, for some, I think usually most students, I don't know which one we prefer. I prefer something that is visuals, like graph. I think it's easier to understand rather than like words, right? Maybe I'm not sure whether you prefer like when you see the graphs and then you see the words. I think most people prefer the visuals, the graphs, right? Yeah, that's for me, but I think everyone has different perspective, but that's okay. All right, and then what else we need to cover today is this is not need. Oh yeah, combination of functions. Okay. So combinations of functions. Well, the first thing is if we sum or if you subtract, we can make a sum product or quotient, multiply and then divide the functions. We can make out, for example, the first one. And if you subtract, let me just add minus below this one, which means it's the same thing, the same form. And if we take the product, this is not by any means fg multiplied. It's not multiplied, but it's a function. But the functions is usually we have the f, right? But this f now is f multiplied with g. Okay. We can also say that this is just multiplying these two. And if you divide this is dividing this two. And of course, when you reform or transform the functions, of course, the domain also can be changed, right? Can be changed. So that's also one thing to keep in mind. The domain can be changed. And then another way, still in the combination of functions, there are another way we call the composite. Okay, the composite. I think you learn the functions is junior high school, right? Functions. The first time you learn functions, right? Junior high school. Right? Okay. Okay, let me go through the next page. Okay, if you still up here. So composite. So composite means there are two components. Okay. Either you learn maybe learn something about material science. There are materials called composite which compose of more than one materials, so they can combine. And this is actually similar understanding. So we have different functions, and then we combine into one. Okay. So let me just write given two functions f and g composite. We usually write composite as f, and then there's like a circle. It should be smaller than the letter O. Okay? The correct symbol. Composite is okay, defined by so we define this by when we have f and then like a circle g. So f composite g is the function g inside the function of f, or f of g of x. Okay. It's just a symbols uh, that makes the functions after the circle supposed to be inside the functions, the first one. Okay. That's how it means. Okay. So it's like I'm not really sure like the history part why they put the symbols, but uh, the way that I look this problem is first it the people maybe mathematicians they try to make like a functions, and then they try to put the function inside another function, and they want to make some symbols, and they want to make something that is easy to be followed. Okay, so they make this like circle symbol. And of course, because this composite, they define by the two functions f and g. So we are going to assume that the domain already defined for all of this. So let me just write here. So uh, domain of f of g is the set all x in domain of, let me write it blue, of g such that g of x and f of g of x, they are all or just already defined. It's okay. So if you want to assume that the composite works, then we need to assume the variable inside also defined. Okay? Which means that if I think yesterday we tried some a little bit question on how to find the domain, right? So from here we are going to like if we have like combination from from two domains, then we need to like having some interval that where the function is defined, right? Okay, that's how we are going to look at this composite. So I think if we have time, we can have some review and exercise. Yeah, this is composite. So a typical questions. Uh, First is, of course, make the composite itself. Okay. For example, let me just take some questions. So let's say find f g o g o h. That is just a simple functions. So the composite can be as many as possible as you want. Okay, like maybe inside the function, more and more and more. It's possible. It's up to you. It's up to the one who designed the functions. Okay, you can design any function, anything that you want, right? Design your interval. Okay, design whether it's piecewise defined function. Okay, and I think because you can design everything by your own, when you learn later, like how maybe you deal with some research in the future, you will know like when you simulate in some maybe software and try to make some models, like you can design that by your own. Like maybe you need to maybe read some paper and then make some modification on that models throughout the process. Okay. So anyway, uh, this means the f inside G and inside. So first we are going backwards from H, going to G, going to F, right? So we are going to, from here, x squared, we are going to put inside here, and then going to put the whole thing here inside here. So this will be going to be 3 sine x squared minus 2. Okay? I think the logic is should be like following the back side of the function, like the inside of the functions, and then going out layer by layer. Okay? Okay, another type of questions is, let me write, um, where is it? Okay. Like if f of x is x plus 4, h of x is 4x minus 1, wait, fine. Function g such that g of f is equal h. Now there's something that you need to do some trial, or yeah, some trial at least. Okay? Okay. Anyone find?
4x minus 17.
Okay, good. Okay, so perhaps we can start from G, not H, F, right? And then this should be equal with this, okay? So this should be equal to 4x minus 1. And this part, we don't know yet what kind of function of g is, but we still just write down the possibility that is x plus 4. So what we're going to do that this x plus 4, when we put into g, there will be 4x minus 1. So what we are going to do here is we are going to settle that this part of x, okay, we can say that we are going to have. So when we first is we maybe not maybe let me just explain from the scratch. So one way to think that the end result it should be 4x minus 1. It has to be like having the 4x, right? So what we are going to do look from this x plus 4 is when we put x plus 4, let's just imagine we put into some a, okay? When we put here, this x plus 4 should be 4x minus 1. So it should be multiplied at least by 4. Okay? It should be multiplied by 4. By 4. So if we imagine this 4 and a is x plus 4, so 4, x plus 4, this is going to be plus 16. But we want to have minus 1. So we need to minus the 17, right? So we are going to have 4x or 4x plus 4 minus 17. We should have this, right? So at the end, we know that the result should be 4a. Let me turn back this into the 4a. Should be 4a minus 17, which means that this a is our x. So let's just check that our g of x is 4x minus 17. So we could check that we try to make this x plus 4, which is this is going to be plus 16 minus 17. So we are going to have this one, okay? Okay, I hope everyone got my point. Yeah. Oh, okay, okay. Maybe let me go back through here, okay? Okay. So we want to have 4x minus 1, right? We don't know yet what kind of functions g is. Well, maybe to make it easy, maybe just let me put maybe g is having some variable x, okay? So when we put here, we should have, if this is just x, then the result is x plus 4. But what we want is 4x minus 1. So we need to multiply with 4, right? And then, if we imagine this is x plus 4, and if we multiply, it results in 4x plus 16, right? 4x plus 16. Now 16 and negative 1, their gap is negative 17. So that is what we are going to achieve. So we need to make it negative 17. So we are going to have negative 17. Why? Okay. Yeah, sure. Okay. Okay. Um, okay, I think the rest of the exercise, if we have time, we can deal with that later. And also you can deal the exercise with the teaching assistant. Okay. Okay, I think I'll just continue on. Okay. Yes. Um, my goal for today's class is maybe finishing all the chapter one, because I think most of the section is review. Okay. Okay, if you have anything in mind, and maybe questions or discussions, you can raise your hand, or if you feel shy after the class, you can discuss with me. Okay. Okay. Now the next part, after the composite, we move to the other sections. We are going to just review the exponential functions. So first, let me just write the general terms exponential. And usually people use the words exponential to describe something that is significantly increasing, or is, or we can say it's when we say something increase exponentially, so the increase should be follow the behavior of the exponential. So we need to know why exponential becomes really important, okay? Especially when we deal with the population. The population should be deal with the exponential, okay? Statistics, exponential, right? Okay. Now the general rule is exponential is just b with power of x. B is let me write here. B is a positive constant. We call the base usually. So usually we call the base. And base is something that is also appear in logarithm because they both are inverse each other, the exponential and log. So if x equal n, uh, let's say positive integer, then if we have b with power of n, this means that b multiplied with b has n factors. And if x equals 0, then b with power of 0 is equal to 1. And if then b with power of negative n is just reciprocal. Okay, it's just standard things related to exponential. And we can also make this n as a rational. So b over q, I think too small, let me make it bigger. Or we could say this, and then with power of b. This is just a standard, or maybe make this going to the left here, so I will have much more wider screen. Yes? Uh, which one?
There's a E on the rug.
Oh. Oh, yeah. Why I write P? Okay. So I have right here, like, if the x positive integer, but it also confirm that when we have irrational number, this is also true. So we can define that uh, let's say, let me write that to the left. We can define when b is positive and x is irrational number. So by the end of the day, when we have a functions, let's say, to the power of x, and x is real number, or let's just say x is element of real number, then we can draw the plot. Let me just draw for you here. Okay, it should be okay. Not quite correct. Should be a little bit steeper. Yes. Irrational. Irrational. Sorry. My bad. Is irrational. So this irrational number, we can try to check. Okay? Can try to check with some trial and error and try to check. We can check with the square root of 3, which is we can find some inequality to prove that we can make this square root of 3 between some numbers. For example, this numbers is make the square root of 3 in the middle. And then with this, we can turn out to our functions that, for example, if we have the base 2, for example, this part is base 2, so we can make the base 2 and then makes power with square root of 3, which means that this is also true, that this is going to be in between these two numbers. Okay? Yeah, let me explain. I think because I don't want to explain all. So at the beginning, I said that uh, b, the base, is a positive constant, right? And we check with the positive integer, which you have familiar with. But the question is, if we can make this rational, like the p and q, how about the irrational, which is we cannot really make out the rational forms, right? It's still the decimals, the long decimals, right? How can we make sure that the long decimals and we put into our base, it's belong to the exponential function? How do we make sure? So how to do that is we can check with some of the irrational numbers and we can try to do some approximations. Okay, how to do the approximation is basically we need to check the numbers in between the not in between. That is the irrational numbers in between of that numbers. Okay, so we can check first this number, and then we can approximate with others as well, because irrational has a long decimals, right? What I did is just makes the two decimals, so we can check with other number as well. Like for example, 1732, or maybe 20 blah 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 205 blah blah blah. Okay, we can check, and then we need to check that, and then we make sure that the number itself is in the irrational one is in between the decimals, okay, the decimals and the function itself with base of 2. Okay, so when we did that, we can define that the the irrational number that is in the base is on our function. Okay, that is what is going on. Okay. So practically, what we did here is to make out this this to compute this through some approximation. So we will have to be ended in some results that is in between of the left numbers and the right numbers. Okay, that's what's going on. So we need to prove that there is a number that is greater from the left side, 2 with power of 1.73, and then there is a number that is precisely less than the 2 with power of 1.74. So we are going to take some approximation, and we are going to have like a lot of trial and error because it's irrational number. So we are going to make sure that this is have some these decimals. Depends on our approximation. Okay? When we are ending our approximation, if we want to end with the 5 decimals, 6 decimals, okay. This is short summary, which is short summary just to prove the irrational numbers is on the exponential functions. Okay. Well, the thing is, what is the most interesting on these exponential functions is how we can find the natural number e, and how we can use that natural number in many ways. Okay, in many ways. And then maybe before that, we can see these exponential functions also can be transformed. Okay? We can also multiply with some constant and maybe multiply with the less than 1, or between 0 and 1, and then greater than 1. Let me put that on into the next page. Okay, so first we are going to focus on the base is 2, so 2 with power of x. Okay, so if we change the base, for example, we change the base, make it into 4, we will see that it's going to be here. So what does that mean is it's going to have, or it's going to be getting steeper, steeper, and steeper faster than the two, right? That's one property on the exponential functions. Okay, so you will see that at some x, when you put some x, you vary the number x, you will see that the exponential will going to be, they are moving very fast. They are getting larger very fast. That's the interesting part on the exponential. And if you see when we have, like for example here, we can write that this is, we can write 2 with power negative 1 x, or we could write 2 with power of negative x. Right? So when we have this, we will see that it's actually, it's mirror the 2 with power of x, right? And that's also one property on the exponential, right? And then same way for this one, this is for negative x, and this, we can see that it's mirroring the 4 with power of x easily, okay, if you see. And if you remember what we did with reflection, it's also consistent, right? Also consistent with the previous one when we mirror with the y-axis, okay? Okay, now that's one way to see the transformations. And another way is, let me check, I think this one. Yeah. This is what my explanation before. Okay. So when b is positive, we see that I said this is the default way to see the exponential. The default is this one. So when you are making it into, because the way you see this exponent, when we change the b, only two ways that is possible. Okay. The b is positive, or the b is from 0 to 1, or it's rational. Yeah. Okay. Rational but less than 1. Okay. So then this is the mirror. The mirror. Okay, we can have a break. So maybe 5 minutes break. Okay. Hello, hello. Hello, hello. Okay, I think we can continue. Okay. Uh, continue just a little bit, finishing the exponent, and maybe up until the inverse and hopefully logarithm, but I'm not sure we can finish all that. But let's try. Just I think this is the last one on the exponential. Uh, this is just an introduction to the Euler or the E, the number that or we call the natural number. But I will just explain like a short summary from the graph. Okay, so if we look at this, uh, okay, wait for me. Okay, if we look at the tangent line, the tangent is, of course, it will be the next chapter, but let me just tell you that this tangent line is when you have this curve, the 2 power of x, and at this point, let me write this point here, this is at 0, 1, we are going to have our tangent line at that point. So basically what you did is the tangent means tangible, which means it's going to touch on the curve exactly at that point, 0, 1. So what we did here is we make a line that has some gradient, okay? That has some gradient, and then it starts the 0, 1, okay? And the important thing in this graph is from that gradient and that tangent line, we know that we can have a ratio, right? Ratio from this triangle. Let me put here the ratio for this triangle, right? And that is how you find the gradient usually, right? From the I think you learned the gradient also junior high, I think junior high. So we know the ratio, and the ratio is said to be 0.7. Let's say we already calculate, and then it's 0.7, okay? And that is for this 2 with power of x, okay? And then we have 3. We change the base, and of course, it will change our computations also, right? Our calculation will be different. And we did the same thing with this 0.01. We take our tangent line on that point, okay, on that point, and then we can see that we have also another ratio here, our triangle here, right? And if we compare these two, the first one is 0.7. The second one is 1.1, okay? Now the idea behind this visuals, the graph, is can we make the gradient equal 1? And can we find what is b? Okay, so if this is our b, we want to find the gradient at 0.1 is 1, or the tangent line, or the gradient on the tangent line is supposed to be 1. Okay, so we can find our b? Well, there's some way to look at some methods. One method that is easy for you also to compute is just try some numbers, right?
Derivative.
Yeah, that will be left into that. But before we learn derivative, there will be something that we can try directly. So first is we need to think a number that is between 2 and 3, right? And we can put like from 2.1, 2.2, and so on and so forth until we get the one that is approximate to 1. And actually, from that point of view, that is one way to get our number e. So our number e, this one here, this is supposed to be 2.7, 0.8, blah, 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 right? It's also irrational numbers. That's one way to get e. Okay? We will learn more about this e when we learn about derivatives and how we get also to look at the e with limit. Okay, but for now, this is how we can exactly get the e from comparing the base on the exponential functions, the base 2 and 3. And then e is in between of those two. Okay? And then later on, when we see some case, well, in the populations, statistics, even finance, we will see there's also like e appearing as their as a sum ratio in some of the equation, and that's why we call e is also, it's called the natural number. It comes out in nature. The ratio comes out in nature. So e and also the golden ratio is also we can see on nature. Okay. Well, I think it's not 8, it's 1/8. Sorry, 1/8, 2/8, blah blah blah. And we develop a new function called e with power of x, the natural exponential function. So we will learn more about e later in derivatives part. So yeah, finish about exponent. Finish about exponent. Okay. We'll just let you write some notes. Okay, now after this exponent, we move to the inverse and then the log. And then yeah, that's all the chapter 1. Okay. Okay, I hope I can move to the next page. Okay. If you still want to write, okay, I give you a couple minutes. Okay, so let me go to the next page. So this is the inverse. Inverse of the function. Inverse of the function. Okay, if the function is f, usually, if we are already know and familiar with the inverse, you know that we write f and then -1 at the top means that is the inverse of f. Okay. Now, what is inverse? Okay, what is inverse? Maybe anyone can maybe you can describe what is inverse in your own words. Anything?
Yeah, this is, I don't know how to say it in English properly, but when we have a line y equals x, it must be mirrored.
Yeah, yeah.
Like
In
that,
some sense, it can be mirrored. But let me just rephrase what Peter means. In my opinion, inverse. Let me just write first. Okay, just exchanging the domain and range. Okay. Or sometimes you can simply see the x and y, but it's not exactly x and y, but in more official, it's domain and range. We will see later. But before we going into explanation what is inverse and how we can deal with that inverse, we are going to look on how can we know that the function has an inverse, right? How do we know that the function has an inverse so that we can exchange the domain and range, okay? So first, let's go back to our idea from the very first explanation on the function. Okay, and this one. Okay, now both are functions. Both are okay as a function, but we say the first one here is exactly from the left side, from the left domain, they are going to the other element exactly one by one. Right? We call this the function. The function is 1 to 1. And then the second one, although it's a function, it's not 1 to 1. Okay? Because the second arrow and the third arrow, they point out the same value. For example, you can see easily if we have a typical x squared, the typical x squared. When you have the positive one here, and the negative version will also have the same value, right? The same value here. So we are not saying that this is 1 to 1. Okay? It's not 1 to 1. But of course, if you maybe remember what you are doing back in high school and maybe learning the inverse, you know that the x squared has an inverse, right? X squared has an inverse. This is the square root, if you remember. But we see that this is not 1 to 1, and the requirement for the inverse is need to be 1 to 1. Okay. Now we have a problem here. But if we cover or if we erase the left part here, we solve the problem. Okay, we solve the problem. We have the 1 to 1 functions now. So again, the domain plays an important role. So we can restrict our functions on some intervals to make it one-to-one functions. Okay, so let me write this. Let me write function is one-to-one if, let me just write the conclusion, fx1 is not the same as fx2 whenever x1 is, so they need to have exactly one value to one value, okay, and they are not the same value. Okay? The result of the function is not the same value. Okay. Why we need to have one-to-one function as our requirement for inverse? Because we want to make exchange on domain and range. If they have the same value, the exchange process will be difficult because some of them are the same value. So we need to cover the other part. Okay, for example, let's see this x squared again. If you want to exchange the domain and range, if we going to use the full graph of the x squared, can you imagine, like, imagine the domain and range getting exchanged? It's a little bit difficult, but if we erase this, and if we do some calculation later, I will explain, we can see that it can be like that. Okay. Okay. Now, if we turn on back this one-to-one functions, one way to look at the functions, how to try whether it's one-to-one or not, let me just go back and write the x squared. If we draw line, because if we have one-to-one functions, we need to have the fx1 is not the same as fx2. So if we try to make the line here, you see that it's crossing these two, right? It's crossing these 2 points, which means it's not one-to-one. Okay, so this is one way to check the one-to-one function. We call this the horizontal test or horizontal line test. So one-to-one if and only if no horizontal line intersects its graph more than one. Or you can write it will be not one-to-one if they intersect more than one. Okay. Or if we draw more clear here, okay. Okay, maybe any question in mind or something to discuss? Anything? Um, So first, you can determine the functions with vertical line, and now you can determine the functions one-to-one with the horizontal line. Okay. So now you can have more ability to see the functions. For example, trigonometry. We have sine, cosine. That is always looks the same, right? And if we write the horizontal line, it's going to be more than one, of course, right? So we know that it's not one to one. But we know that we have inverse of sine, right? We have arc sine, right? So how do we get that? Again, it's the domain plays roles. Okay? So if we restrict on some domain, we can have the inverse. That's why we have the sine inverse, cosine inverse, and tangent inverse also, because we restrict some domain. Like we did on this x squared, we just cover the other part, and it's one to one. Right? Okay, now the definition of the inverse. I think I will go to the next page. Let me write maybe here. Maybe a little bit here. Okay. My tips for you. I know that the freshman, you need to take mostly fundamental courses, right? And some fundamental courses, they will or they should exhaust your mind for study, right? So sometimes it will be a little bit tough. So your study usually freshman a little bit tough, going tougher. Uh, I think in the third year a little bit slow, and then fourth year stable. Okay. So this first and second year going to be tough and tougher. My tips is stay healthy. Okay, stay healthy. That's important. Stay healthy, body and mind. Okay, body and mind, mental. Um, for me, it's okay if you want to like skip my class sometimes. That's okay. That's okay. It's not like really a big deal. Attendance is only 5%. Okay. And if you have some, usually you will have different kind of either homework or either project or maybe quiz like in other courses, right? So if you have that and you need to study for that, you can just like skip my class for a while. That's okay. For me, that's okay. As long as you keep catching up, okay? I will always record my lecture, so you can always review. Okay, you can always review. Like like I think it's quite normal, and I don't have a problem with that. And also, I don't have a problem if you take some rest in class for a while, okay? Because I know the schedule, your schedule is quite bad. The schedule is quite bad. So I'm thinking it's quite normal, but you need to catch up. Okay, you need to catch up. All the contents, materials, and you can also surf websites, browsing some stuff, right? Usually, people writing some like the solution problem for blah blah blah. You can just look at that up, but always thinking that what you read is not always the truth. You need to know the core concept, how to understand the concept first. Okay. So my thing is everything that you done, that's okay. That's okay. Okay. All right. Now back to the lecture. Okay. Let me write some words first. Okay. The definitions. So let F be one-to-one function with domain A and range B. Okay. Then the inverse function that has domain B and range A. So you notice that this will be exchanged in domain and range, defined by f inverse y equal x. This is equal or the same as f of x equal y for any y in B. So look at this domain and range. The domain and range, they are practically exchanging. So we can say, let me write maybe on the right side here, some notes here. So domain of f inverse is equal to range of f, and range of f inverse is equal to domain of f. So as mentioned by the symbols or letters A and B, so if we make this is A and B, so this is A, this is B. Now this is the F, okay? Domain A, range B, and this will be the F inverse. Domain B and range A. And then one thing to remember for the inverse, when you have F, the negative one, F inverse, it's not the same as the exponent, okay? It's not the same as exponent. It's not 1 over F, it's F inverse, okay? F inverse. To know how to differentiate between two of them, you need to know the context. Okay, usually you know from the context in the if you have like questions or problems that need to be solved, they will give you some context that it should be asking inverse, not the way around. Okay. Okay. Now some property I will just write this property. I think it's intuitively okay. I think not really that complicated. So we can also write with this exchanging the x and y, still the same, still okay because they exchanging each other. And if we have f inverse, and then we have f of x inside. So how to describe what process for this f inverse, but it has f of x.
We get it.
So it's going forward but backwards, back again. So it's back to to x. Okay. I hope you get the logic. Okay? I hope you get the logic. Okay? So we can say this for every x in A. And then we can also write same thing, but we are writing the inverse inside of the f. This is also the same. Okay, now how practically we find the inverse from a functions. Okay, so how to find inverse function, inverse of one-to-one function. So first, write the functions in terms of y and x, okay, because this is important. Now, because we need to change the domain and range, so practically what we need to do is we need to exchange the y and x, and we need to solve in y. Okay, solve equation for x in terms of y. And then express the f inverse by function of x, which means we're going to substitute back to or interchange the x and y. Interchange, let me write with blue. All right. Interchange, maybe not really clear. Maybe here. Interchange x and y. And the result should be in the form of y equal f inverse x. Well, it must be if we need to try this, we need to try with the with some functions that we can make sure that it's one to one and we can have the inverse. Okay, so let's try to do that. Yeah, to make the inverse. Okay, so we can find the inverse with equation with mathematically interchange the domain and range, interchange the x and y. And later, the second part, we can also find the inverse with the graphs. Okay, with the graphs. Okay, find the inverse. Let's say we have a functions. Now let me add the functions. So find the inverse from these two functions. So find the inverse. Okay, so first, practically, what we need to write, we need to include y in our calculations because we need to use that y in our computations to make the exchange between x and y. So we first write this, okay, and we need to solve the x in terms of y. So we can do this and this, okay. So we get that x is cube root of y minus 2. And then we interchange x and y. We interchange x and y because we want to write in the variable x. Okay, so we can write this in terms of x. So the f inverse is this. Okay. Okay, I think not a problem for this one.
No.
Now, if we look at the second function, now we are going to do the same thing here. So we are going to have y and 2 plus squared x plus 1. And we need to solve this. Okay. We need to solve in terms of y. So we are going to take the squared to remove our square root. Okay. So let me just write y minus 2 squared, and this will be x plus 1. So x is so interchange x and y, we get y x minus 2 squared minus 1. So g inverse of x is equal x minus 2 squared minus 1. Okay. And don't forget these two cases, we need also to look up the domain that we need to consider. So basically, what's happened between these two is we are going to see that at the beginning here, for this function here, we have plus 2. Okay, we have plus 2. So because 2 is a constant, so y should be started with 2, right? Okay. And this is also the same. So we need to keep in mind that the y value is going to be greater than 2 or equal to at least, okay, because of the constant 2. Okay. Now, because we have this domain, then we can say in here that the domain should be x greater or equal to. This is to make precise, okay? But depends on the question whether you need to consider domain or not. At least this is the way or method to find, okay? But in some cases, you need to also consider the domain. Okay, consider the domain. Okay, let me, if we have, oh no. Okay. Okay, now the next section here, let me draw. Let's say this is A, this is B, so this is A, B. And let's say we have another one here, the same value as B, and this is the same value as A, and this is the value. So this is BA. So B and A is just value. So maybe we can say B is maybe 1, maybe 2, and A is maybe 4, 5, 6, any number. So if we think on the functions and its inverse, okay, if we write the functions, when we put, let's say, A as it in this variable, it should be equal to B, okay? And this will happen if the F inverse is also the same. Exchange the B and A. So if we look, uh, what's going on here is actually this 2 point here, and if you can try for some real functions, try some numbers, and try to that inverse, you will see the correlations that these 2 points, when you have the inverse and the functions, they will be mirror each other within certain line y equal x. So you can have the inverse if you mirror the functions through the line y equal x. Okay, and you can try with all functions that has one-to-one functions. Okay, so you can say that the graph of the f inverse is obtained by reflecting the graph of the function f about line y equal x. Okay. Maybe I will write this f inverse with blue to make it clear. So that's why I think at the previous page I say that the x squared, if you want to try to predict, this is x squared, let's say x squared, and then try to make the line, let's say y equal x, you will see that this is going to be here. Well, it's not proportionally correct because I think the x squared should be steeper, but anyway, this is just to show you that we have the inverse here. And the inverse is y equals squared x. You can check with the GeoGebra if you want. Okay? You can draw the functions, draw the y equal x, and draw the inverse. Okay? And you will see that the functions will be reflecting through the y equal x. Okay? And that's how you can also see how the inverse can be observed. Okay? Yeah, I think we don't have much time, so I will just stop until here. And we are going to to have some game, maybe 5 minutes game, 5-6 minutes game. And at the end of the game, I've put some form, or some form, so you can write your ID for attendance. Okay. Okay. Okay, I think I will stop this share screen, and let me go through screen 2. Where's mine? Oh, where is this? Oh, here. Yeah, this is with your hardest thing. Okay. Okay, everyone have joined. Okay. So, okay, use your ID for score. Yeah, that's me. Okay. Okay. Okay, get ready. 1, 2, 3. If it's too small in here, just use in the phone. I think it's giving you quite time, 2 minutes. So I think we can finish on 5 to 6 minutes. Yeah, I think if this, I think too small in this experience. I think in your phone maybe better. The resolution better in your phone. I think some lecturers do this kind of things too, but I think.
Put my name. Sorry, I didn't put.
Oh,
put on.
yeah. Okay.
Sorry.
That's okay. That's okay. That's okay. Okay, 1 minute. Did you enter which name? Random name. I think you can, at the very end, you can just write something related to what you are writing in the name. That's okay. That's okay. I'm giving the last page. Okay, 2019. Okay. Okay, 3, 2, 1. Okay. Yeah, I think good. Good. For this student. Correct. Okay, get ready. Okay, I still have two more questions. See who are the winner. Okay, this should be IATP. Who is it? Ritu? Huh? Okay, okay. Okay, next one. Okay. Okay, get ready. Okay, 3, 2, 1, start. I think you can check. You can check it. It's just matching the graph with what functions it is. I think it's kind of giveaway. You can just see the functions and the interval, and you can check which one is the most makes sense. I think it can be faster. It can be done really quick. Right? You can just see the interval, and then see the functions. It can be done really quick. Okay. And don't worry if you answer wrong, but don't worry. So okay, this is to check, just to check. Just to check. Okay, easy one, easy. Okay. Okay. Okay, cool data, cool data. Okay, one more. Get ready, one more. Last one. Odd or even or neither. Okay. Yeah, I already give the options. You can choose which one is the most makes sense. Okay, remember what is odd functions, even functions. Okay? It's related when you put the negative variable inside. Okay, 20, 22, 21, 20, 19. After this, there is one slide just to write your student ID, okay? Just to make sure you are doing this. Okay, okay. Good. Good. Okay, let's see who is the winner. Oh. Okay. Oh, who? Who? You know? Oh, okay, okay, good. Okay. Now, last one. Please write the student ID again, just to make sure that to confirm that you've done this game. And then, if you have any suggestions, please write. And if you write wrong name with the quiz, you can also write here your student ID and your name or your random name in the game. You can write. Okay. Okay, if you're done, then finish. You can leave the classroom if you want. Okay, if you're done. Okay. And thank you for the class. Okay? Thank you for joining my class today. Okay, see you. Yeah.